Allison from East Cobb Tutoring Center. Today we're going to look at a rational function that has a slant asymptote and how to graph it. So first, just to remind you, a rational function is one where there is a fraction where the polynomial is in the numerator and a polynomial in the denominator. And a slant asymptote happens when the degree of the numerator, degree of p, is greater than the degree of q. So that's the kind of problem we're looking at. And the example that we're going to do is right here. So let's do y equals x cubed plus x squared minus x plus 1. And then underneath, we're going to have x squared plus 4x plus 4. So we have a slant asymptote in this problem because the degree of the numerator is 3 and the degree of the denominator is 2. So we need to use long division to find the slant asymptote. So here we go. I'm putting the numerator in here. It was x cubed plus x squared minus x plus 1. And I'm dividing it by x squared plus 4x plus 4. Got my x there. All right, so for polynomial long division, we're thinking about how many times, or really x cubed divided by x squared. Let's undo that crazy line. X cubed divided by x squared is x. So I'm going to write that up here in the x column, and then I'm going to multiply. So that gives me x cubed plus 4x squared plus 4x, and now subtract, so it's just like regular division. Okay, let me scroll up a little bit so we have some more space. And that gives me, let's see, negative 3x squared and minus 5x. Okay, so the next thing we do is we divide again. Negative 3x squared divided by x squared. That is negative 3, so that goes up here in the ones column. And then I multiply. Negative 3x squared minus 12x and minus 12. And I subtract again. But this time, when my squared things cancel, I'm going to be really just down to a x to the first power term. And that's where we stop, because if we do x divided by x squared, we're going to have a remainder. And for a slant asymptote, the remainder doesn't matter. We just dump it. The stuff that we have up here, that is our slant asymptote, x minus 3. So let's go back to our original problem. And let's remember that our slant asymptote was x minus 3. The line y equals x minus 3. And also, we need to take the denominator, it was x squared plus 4x plus 4, and set that equal to 0 to find vertical asymptotes. So if you have a slant asymptote, you're not going to have a horizontal asymptote for these problems, but you can still have vertical ones. So if I solve this, I get x plus 2 and x plus 2. So the vertical line at x equals negative 2 is my vertical asymptote. All right, so let's draw a picture. Let me put some graph paper up here for us. Okay, I hope you can see that. It's kind of light in color. And let me put a coordinate plane on. There. And let's go an x-axis right here. And there we go. All right, so let's start with the vertical asymptote at negative 2, which is right here. There we go. So it's a dotted line because it's not actually part of the picture. And remember, a vertical asymptote is like an electric fence, so don't touch it. And then my slant asymptote has a y-intercept of negative 3. Sorry, it's a little hard for me to see my graph paper. The slope is 1, so up 1 over 1. So something like this. I'm doing my best here. Okay. All right, there we go. And now we just need to figure out where our function is going to go. The best way to figure it out is to plug in points on either side of the vertical asymptote. Those will give you the easiest numbers to deal with. So the original problem again was x cubed plus x squared minus x plus 1. And the denominator was x squared plus 4x plus 4. So because the vertical asymptote was at -2, I am going to plug in -3 and I'm going to plug in -1. So let's see here. I'm making like a little t-table. If I plug in -1, let's see, that's going to give me -2 over 1, so that's going to give me -2. -1, -2 is right here. Right there. So that tells me that this thing up here looks sort of like that because it has to get very close to the asymptotes. So I already know that my other one is going to be down here on the bottom, but it would be a good choice for me to plug in anyway. So I'm going to pull up my calculator here and let's plug in -3. So I'm going to have -27 plus 9 plus 3 plus 1. That'll be my numerator. And my denominator is going to be 9 minus 4, minus 12 plus 4. And let's see what that gives us. -14. Alrighty, so it is way, way down here, way low, lower than my graph is going to show. So we just kind of have to imagine that it's going down close to our asymptotes, but never touching them. So I think we're done. We've got vertical asymptotes, we've got slant asymptote, which we found using long division, and then we found the shape of the graph by plugging in a couple of points.